In this paper, we propose techniques for modeling and rendering the subsurface scattering effects of heterogeneous translucent materials. Specifically, we present a technique for acquiring material properties from surface appearance measurements of physical samples, and also an algorithm for real-time rendering of heterogeneous objects of arbitrary shapes. Our rendering algorithm supports real-time editing of material properties. Here's a bunny rendered in real time. The bunny's material has been acquired from a real-world material sample shown at the bottom left. Our work is based on the diffusion approximation, which uses the diffusion equation to describe multiple scattering within an object. The diffusion equation is defined inside the object volume. The boundary conditions of the diffusion equation are defined on the object surface and depend upon the lighting conditions. Solution of the diffusion equation yields the multiple scattering component of subsurface scattering. To render an object with known material properties, we need to solve the diffusion equation with the boundary conditions determined by the given illumination. For acquiring material properties, we first measure the surface appearance of a material sample under different illumination conditions. We then acquire the material properties inside the object volume by solving an inverse diffusion problem. Please see the paper for details. Here we show our measurement setup and the capturing process. From the recorded images, we acquire the volumetric material properties shown here. Here we show the appearance of 4 heterogeneous materials captured using scanned light strips from behind. Now we show some results. First, we show a bust model that is composed of marble acquired from the real material sample shown at the bottom left. Note that the complex surface appearance caused by subsurface scattering and volumetric material variations are well preserved in the acquired material volume. Now we show a bunny modeled with wax. The material is acquired from the wax blocks shown at the bottom left. With our rendering system, the subsurface scattering effects in the object volume are well reproduced under directional lighting. In this demo, the bird is modeled with a different wax material. The heterogeneity beneath the surface is well acquired from the material sample and successfully rendered with our approach. Here we see a rendering result of the bird with another artificial stone material. Our techniques allow the user to interactively edit the material properties. Here we show a simple editing tool. In our system, the user can easily modify the existing material attributes or paint new materials into the object volume. The subsurface scattering effects of the modified material are rendered in real time. The volumetric material representation also allows the user to modify the material properties at different depths beneath the surface. Here we show the bunny rendered with different materials that have been edited by the user. Now we show more editing results. Finally, we show a snail rendered by our system. The material for the snail body is modified by an artist using our editing tools. In conclusion, we proposed efficient techniques for acquisition, interactive editing, and real-time rendering of heterogeneous translucent materials using the diffusion equation.